And before we start, just want to have a quick open-ended question for everyone. So, how many of us here have any experience with anything with respect to, let's say, ICE or any other network access control solution or AAA, for example?
I have used it for troubleshooting purposes in the work.
Okay, great.
And then I have checked live logs and saw like where the chain is failing and all. Never
Okay,
deployed, but
okay,
I have used it.
okay. Great. Anyone else? I know done worked with not necessarily ICE, but AAA in general. Maybe has worked with Radius or Tacacs, understands what those protocols are. Why would you use one versus the other? How would you kind of design them properly? No one. Okay. All right. Yeah. So no worries if you don't have experience. Okay. So the way that we will do this is we'll be understanding what AAA is first. Okay. And we'll understand what the different protocols are, what goes into was anyone saying anything? Okay, never mind. What protocols or algorithms go into implementing AAA? And then we'll see how ICE does things. Okay, so if maybe if anyone is here who might have worked with something like ClearPass, for example, or maybe Fortinet. Fortinet has the product as well. They're not as extensive and as comprehensive as something like ICE or maybe even ClearPass, but they do basic radius, they do basic NAC. Okay, and then within the context of ICE, will really try and understand what or how do you properly design an environment. Obviously, we'll be looking at the various aspects of implementing it and deploying it as well. Okay, so it is going to be very hands-on heavy. Okay, so the initial couple of sessions, they're mostly going to be focused around me discussing various protocols and everything because they're important. As much as ICE is important, you need to understand, the actual functionality of the of AAA in general. And then once we have out of the way, it's mostly going to be a lot of lab time that you need to or will be spending time over. Okay, so and obviously feel free to ask any questions if you have. Okay, it's good to keep things interactive. So people who are, like I saw, someone is new to the domain. Okay, so for folks who have never worked with anything AAA, they don't really understand radius or anything comparative to it. You will really gain some knowledge out of it. For experienced folks, so we had some of the folks here who have done some troubleshooting with respect to ICE. Okay, so you would gain something out of it as well. Okay, and let me just share this properly. Okay, so let's start and talk about the very important thing why you would do something like ISE or any other NAC solution, network access control solution. AAA. Okay, so it's the AAA is mostly a framework. It's a framework by which you can very intelligently control access to network resources to any devices on the network. You can control or enforce policies. And you can also audit and see basically what's really happening on your network. That's really the goal behind implementing AAA. And you can implement AAA using a variety of different things. And you can implement it on a variety of different things. So before we talk about from the perspective of ISE or networks in particular, or network security in particular, we basically have our AAA, in our day-to-day as well. Okay, so the three A's that we have here, the first A, that's always going to be the first step that happens, which is going to be authentication. Second is always going to be authorization. And the final one is going to be accounting. Okay, so think of it this way. Let's say you want to withdraw some money from a bank account. Okay, now in order for you to do that, the bank needs to verify your identity basically. The bank needs to figure out that you are who you are saying you basically are. You need to provide some sort of a identity. You need to provide some sort of a signature to proceed. That's the process that we call as authentication. And so, guys, you might have access to the whiteboard as well. So refrain from selecting, deleting things. Okay, so I can see folks are trying to fiddle with the whiteboard. So please try to not do anything on to the whiteboard. Okay, let me start this again. Okay, so let me just write that real quick. This is the authentication.
Sir, we can zoom it this whiteboard, and we have this kind of feature available to zoom it.
You should be able to zoom it, but while you are zooming it, I mean, if you do so on the right hand side in the corner, you should have an option to do zoom. So you're gonna see 100% written and then two magnifying glasses there in the bottom right corner.
Yes, sir. I just checked.
Right. So you can use that to zoom into it if you are, viewing it maybe on a laptop screen or something. And then later on, I'll figure out a way in which I can, kind of lock it down and no one can access simultaneously. Okay, anyways. So again, imagine you want to withdraw some money from a bank account. The first step is authentication. This is always going to be the first step. You have to authenticate. And authentication could be as simple as providing a signature, which you typically would do in the form of, when you write a check. For example, maybe if you're trying to withdraw it through maybe, let's say, internet banking, or maybe through an ATM, you provide a PIN. When you're trying to internet banking, you provide a username and password. So it's the process of providing these credentials which basically determines whether you are allowed to have access to your bank account or not. That's what we call as the authentication piece. So, like I said, it could be a username and password. It could be a certificate. It could be a signature. It could be any sort of biometric as well. Retina scan, iris scan, fingerprint scan, face scan. If you just provide a username, that is identification. That is not authentication. When the username combines with the password, that's when it becomes authentication, or that's when it becomes a credential. So if I just take your username, I won't be able to authenticate you because that is just your identity. That is not authentication. So for authentication, I need to have some sort of a credential, something which differentiates two users from each other. It could be a password, an OTP, a PIN, could be a passphrase, be anything. So this is always going to be the first step within the AAA framework. Now, after authenticating and you basically proving to the bank that you are the actual owner of that bank account, the bank needs to verify. The bank basically needs to verify and figure out what are you allowed to do. With respect to the bank account, it basically will govern how much you are allowed to withdraw. That's the authorization. What are you authorized to do once you have authenticated? So let's say I have maybe $1,000 in my bank account. I am only allowed to withdraw up to 1,000, not more than that. So even though I have successfully authenticated, I have proved my identity, the bank has verified my identity properly, it does not give me an all access privilege, or it should not give me an all access privilege. I should not be able to withdraw $50,000. I should not be able to view any other user's banking account or banking information. So the authorization piece determines my privileges, what I am allowed to do, what I am authorized to do. So in case of the banking piece, it would typically be what amount I'm allowed to withdraw. Can I apply to any loans or anything? Am I eligible for a credit card, etc.? Can I apply for a credit card? All of these are basically my authorizations. And they're all tied to my identity. They're all tied to me being wherever that user is, whoever that user is. So that's going to be your second step. My bank could deny me access to my bank account as well. So even though I would have successfully authenticated, I have provided the correct username and password. Due to various reason, maybe I have not, verified my KYC, for example. And this is, talking about from an India perspective. Or I've not provided any other identification, any other supportive documentation. They could not give me access to my bank account as well. So successful authentication does not promise a successful authorization as well. Okay, so this would be privileges. Now, whatever happened from an authentication authorization perspective, when did I log in? From where did I log in? Let's say I'm talking about from an internet banking perspective, the IP address from where I logged into the website, what browser I used, etc., etc. What did I do on my banking account? Once I was logged in, did I transfer some funds? I received some funds. I viewed my um, account statement, my credit card statement. I downloaded all of that information. All of this needs to be logged as well, or should be logged as well for future purposes, for auditing purposes. To keep a record of the transactions that are happening. That's the third step, the accounting. If the authentication was not successful, that gets logged as well. That gets accounted for as well. So at a high level, that's what AAA is. That's what you try to implement, or that's what we will see how we implement that for having a better network security or for having a secure network access. Okay, so if you translate this functionality to a network, in the network, people are trying to access the network through wired, through wireless, maybe even through VPN. Let's say remote users, remote access VPN. You would want to authenticate them first before you allow them access to the network. Even if it is as simple as internet access, you still want them to authenticate first. Now, depending upon what the user is, maybe he is part of the IT team, or maybe he's part of the sales department. Maybe he is a CEO, a CFO, an executive level person. They will all have different authorizations on the network. What resources can they access? And then all of this that is happening on the network needs to be logged, needs to be accounted for as well, which will help in auditing purposes. And then it can also assist and help with troubleshooting if need be for any issues that might arise. So so the combined process here for these three A's is important for a very effective network management and network security. And we use AAA to implement a secure network access. So I'm pretty sure if there are people here who have worked on, let's say, the switching side a lot, right? Everyone would know about port security, for example. Right, that was a very basic security that we used to use, right? Do a sticky MAC address, or maybe have dynamic MAC addresses used, set a maximum number of MAC addresses. If it exceeds, port gets shut down, etc., etc. Right, so that's a traditional way in which we used to secure our networks. Okay. However, that really is not enough in today's environment, where we have a lot of dynamic users. Different users, they could be sitting in different places on the environment in the network. There could be multiple devices that get connected to that single switch. Okay. So for that dynamic environment, just having something like as basic as port security, or maybe having something like a VLAN ACL or a port-based ACL, they're not really enough nowadays, especially. So that's why we need something which secures the network, which enables you to secure the access to your network, to your environment. Okay. So this is going to be our basis for everything that we are going to do or talk about or discuss. Okay. So again, just to summarize, authentication is a process of providing credentials to determine if you should be allowed access on the device or any other resource, for example. Okay, could be username and password, certificates, biometric signature. Whichever device you're trying to access, it would check these credentials against obviously a database. And if there's a match, the access will be allowed. Authentication will be successful. Authorization will always be after a successful authentication. If authentication fails, there will be no authorization, obviously. Even after a successful authentication, it won't mean a successful authorization. And typically, it should not mean a successful authorization. You should not be giving a permit, IP, any kind of an access to everyone that connects to the network. You should always follow the principle of least privilege. The least amount of access that you can give the users that connect to your network. And that access should be enough for them to be able to get their work done. No more, no less. So this is a very important thing to consider. Least privilege principle. Okay, so if it's maybe a CEO, he has no business or he should not have access to maybe something like a database server or maybe financial servers or any of the IT servers, right? Just because he is a CEO, he does not automatically or should not automatically get access to everything. Okay, similarly, someone from a finance department, they have no business in having access to IT servers, maybe SQL servers or any other databases. They should only have front-end access to maybe, let's say, the financial servers. So principle of least privilege. You provide differentiated levels of access in this second step, depending upon the user's identity and their role on the network or within the organization, for example. So you can have different levels of access on a per LOB basis. Sales has some sort of an access, HR has some sort of an access. SOC NOC teams have different sorts of access. Executive C-suite level people have some different sorts of access. So differentiated levels of access. So the authorization process determines whether the user has authority to access certain resources or not. And throughout this, I will multiple times talk about and discuss least privilege. Okay, that should really be the basis of implementing security. provide least privilege to everyone. And then the final step, whatever these users are doing, when did they authenticate? From where did they authenticate? What's the IP address from which I'm getting the authentications? From which IP address are they trying to access the resources? What resources are they trying to access? When did they access the resources? What did they do to the resources that they accessed? All of this needs to be logged. That's where the accounting is. So accounting happens for both authentication and authorization. So I've written it as the third step, but it is not kind of like a separate thing. Okay. So anything that you do authentications, that will get that will get accounted or logged as well. Anything that you do authorization, it will get logged or accounted as well. Okay. Now, how do you implement AAA? And now coming out of the real world example of bank and everything on a network, for example, right? I mentioned you as a user, how would you access your network? Say, for example, at your home itself, you could, plug in an Ethernet cable or maybe connect over wirelessly or even do a remote access VPN if you are off premises. There's just three ways in which someone can get access to network and the network resources. So we try to protect and do that secure network access and protect all three of those mechanisms of access. And obviously, there are some protocols that are there to help us. Primarily two of them. So we call them AAA options. So I'm pretty sure a lot of you would have heard about them. A lot of places seen them implemented as well, but might not really understand the differences between them. So from a AAA perspective, why you would implement AAA? I've already explained why you would do, but primarily from the network perspective, there will be two use cases that you will typically want to protect using AAA. One is obviously network access. That is any sort of wired access, any sort of wireless access, and any sort of remote access. Plus, another thing that you would want to protect is your actual devices, device administration. Your IT team, your SOC team, your NOC team, they typically need to log into network devices, network infrastructure devices. Your switches, routers, firewalls, load balancers, servers, etc. From an administration perspective, for doing configuration changes, pulling configuration, running debugs, extracting logs, doing troubleshooting, etc., running show commands, outputs. That falls into device administration. Okay, so two things that you can protect with AAA: network access and infrastructure device access or device administration. Network access, it is protected through, or the protocol that is used for network access is Radius. It stands for remote access, dial in, user service. Quite a big name. remote access dial-in user service. And there's a reason why it has that name, and I'll explain that later on. Where or why did it got that name? And then the other one for device administration, we have a different protocol that we utilize. Tacacs. This stands for Terminal Access Controller Access Control System. Okay, so they have typically big names that you have for these. These are the two protocols that we will have our focus on, obviously. To understand how we implemented them, how they function, how the functionality is for both of these protocols. How do you implement them correctly and effectively? So talking about Tacacs first, Tacacs was basically designed long time ago. And it has been there from when we used to have Unix systems, mainframe systems. Okay. So the purpose for which Tacacs was designed or developed was for the same thing, for doing device administration. It was created to authenticate and authorize users into mainframe and Unix terminals, as well as any other consoles or terminals. And again, from a device administration perspective, how would you do device administration or do access? You could do Telnet, you could do SSH, you could do HTTPS, right? That's how you will be able to log in or connect to a terminal of a device. So TACACS was developed to protect this device administration. Okay. Now TACACS was, when it was developed, it was a vendor agnostic protocol. Okay. And today as well, TACACS is vendor agnostic. Okay. Cisco improved on this TACACS and they created their own variant. They called it Tacacs Plus. So in Cisco's world, in Cisco's devices, you would always see Tacacs Plus. So Tacacs was vendor agnostic. Tacacs Plus is Cisco proprietary. So the inspiration behind Tacacs Plus was Tacacs. Okay, so Cisco used Tacacs to develop Tacacs Plus, but they are not, or Tacacs Plus is not backwards compatible with Tacacs. So there's no compatibility between the two, even though Tacacs Plus was developed using inspiration from Tacacs itself. So if you have any other vendor, let's say, for example, Juniper devices, and they understand Tacacs, the messages and the messaging and the flow is not going to work with something like Cisco ISE and Juniper. Obviously, there are ways to do it. Cisco is not saying that if you have to buy or if you have to use ISE, you have to have an all Cisco environment. That's not the way that it is. Okay, Cisco ISE does support third-party devices, but you cannot do TACACS Plus. Okay. And think of it this way. For example, let's say we have an AD group, and there are users on my network who, or my engineers who basically try to access Cisco switches, and they need to have full access to the Cisco switches. In Cisco's world, the access level and everything we defined as privilege levels, right? So for privilege level 15 is typically the user exec mode or the privilege exec mode. Okay? So I can have differentiated levels of access. Maybe L2 or L3 folks, I want them to be able to have privilege level 15. And L1 should only have a privilege level 1 access when they try to SSH or telnet into a router or a switch on the network. And on top of that, with Tacacs Plus, I can also control what commands a user is authorized to run on the device when he's logged in. So maybe if it's an L1, I only want them to be able to run any show commands. Only. I don't want them to be able to run any debug commands. So I can configure my device admin AAA or my Tacacs in such a way that even if that user gets authenticated properly, he will only be authorized to run show commands. And he will not be authorized to run debug command. He will not be authorized to go into the configuration mode to do any changes. Okay, so you can achieve this level of granularity through device admin AAA. You can do command authorizations as well with device administration AAA, with Tacacs Plus specifically. Okay, so Tacacs Plus here, it is a TCP-based protocol. It works over TCP port 49. Okay, and both of these protocols that you would see, they mostly follow a client-server model. Okay, so think of it this way. You have this as, let's say, a user, and he's trying to SSH into a router. This router is going to talk to a AAA server. Let me create that properly. So this place here, this will be Tacacs Plus. This here is obviously this is SH between the user and the actual device. And then the network device is going to talk Tacacs Plus with the AAA server. It's going to do the authorization, first the authentication of the user, then the authorization for the commands and the privilege level, etc. And then also the accounting. So this here is a client server model. So this is our client, obviously. AAA client. And this here is obviously the AAA server. The client always initiates the communication with the AAA server. Always. There are exceptions to it. In some cases, which I'll explain, where the AAA server will initiate the communication. Okay, but it happens in very specific cases and it happens to solve some problems, which I'll explain. But for now, just understand, especially in Tacacs Plus, it is always going to be the AAA client, which is going to be your network device, which an admin and engineer is trying to access over telnet, SSH, or HTTPS. Okay, so this router could be a switch, load balancer, firewall, could be any other device. It will always act as a AAA client. Okay, so Tacacs Plus is widely used for the purpose of implementing device administration AAA. Non-Cisco vendors, something like Aruba or maybe Forescout or maybe Fortinet, they have their same AAA solutions. They do Tacacs. Okay, but they also do device administration, like I said, but they do Tacacs. Okay. Someone asked the question, SSH also follows same framework. It's not dependent upon SSH. It could be SSH, it could be Tailnet, it could be HTTPS, it could be any form of access that you're trying to do to a network device. It's the network device which will act as a client that will initiate and talk with the AAA server using that TCP port 49. Okay, so it's this communication here, which is independent of this. This is not dependent. Okay, they both work separately. They are independent protocols. Another thing with Tacacs is that Tacacs also encrypts the packets. Natively. So this communication that will happen between the client. So when this guy, he tries to do SSH, obviously he will provide a username and password. That username and password will be sent from the client to the server because the authentication will be done by the AAA server, obviously. So those packets that will be sent by this client, they will be encrypted. So not the complete packet is encrypted, but the payload is encrypted. And when I say payload, it's that layer 7 data. The part of the packet which will actually contain the username and password. Okay, so it will encrypt the entire payload. It's not doing IPsec. Okay, so it won't encrypt the complete packet, but just the payload. So that's your Tacacs Plus. It does do the encryption of the payload. Okay, so Tacacs Plus typically accounts for about 10% of AAA implementations. Okay, and that's also the amount of time that we will also spend on Tacacs Plus.
I have one question.
Yes.
Sorry. You said that can create only the payload. I'd like to know if the user identification, like user information, will be encrypted or not.
It will be. It will be encrypted. So that's what I meant when I said encrypted payload. The user identity credentials, they will be encrypted before they are sent to the AAA server.
Okay. Redis will not do that.
Right.
Okay.
Radius does just, it hashes the password. It does not encrypt the payload.
Okay, thank you.
Okay. Plus, you need to also understand between the two, they both cater to different use cases. Tacacs Plus is primarily used for device administration. You will not use Tacacs Plus for network access or to implement network access AAA. For network access AAA, you would use Radius, the remote access dial-in user service. And Radius will typically, from a sessions perspective, it will account to the majority of the time that we'll spend Radius. Okay, that will account for 90% of sessions. 10% is going to be Tacacs plus. And again, the principle here for network access AAA and for Radius is to implement secure network access. To learn about the identity of the user or of the device that is connecting. Okay, and later on we'll talk a little bit more about identities. But when we talk about network access, when we talk about people trying to access over wired, wireless, or remote, it could either be users or it could be their devices. So there can be two things which can try to connect or get access on the network. And device could be anything. It could be a laptop, it could be a workstation, it could be a server, it could be a mobile device, it could be a tablet, it could be an IoT device. Okay, it could be something like an Amazon Fire Stick. It could be something like an Xbox. So all of these, they classify as a network access device or an identity. Okay, so for secure network access, it is essential to learn the identity of the user or the endpoint. Things like printers, IP cameras, IP phones, they all classify as endpoints. So we do want to learn the identity of the users, the endpoints, before they're allowed to communicate on the network. And with least privilege. That's what you want to authorize them to have, least privilege. For example, printers. The only thing that the printer should be allowed to talk on the network is the print server. And the printer should be on completely separate, segmented part of the network in itself, where they can only talk to the server, which is going to deliver those print commands to it. Similarly, something like IP cameras, they should only have access to the storage server, which they are going to send the recordings and feeds, etc. to, as well as their management. That's it. Okay, so whatever access the IP cameras should have to get their work done. Do recordings, feed, do storage, get managed, etc. Okay, so there is no purpose in the IP cameras being able to talk to printers. There should never be a communication that should be allowed that way. And you would be surprised to, depending upon how much folks here have worked in how many environments, you would see how common that is for people to just leave the networks open. But hey, it's a printer. What will a printer do? It should have access to everything. Or everyone should be able to talk to the printer. Okay, so that's the first failure point of implementing a secure architecture or a secure network architecture. Always have least privilege, or always follow the principle of least privilege. So coming to the radius piece, okay, which is what you would use to implement network access AAA, which differs a lot to Tacacs. Now you see that name for radius, remote access dial-in user service. So that name tells a lot about why radius came into existence. So do we have folks here from the old modem and the dial-up connection days, where we used to, dial a phone number and then used to have that static that used to hear, and then the internet used to get connected? That were the days of the dial-up. People used to gain access to the internet by using their telephone numbers, by using modems, and this dial-in or a dial-up kind of a functionality. So all that was required at that time was to just have a modem and a phone line. The problem with that was anyone could dial that phone number and get into the ISP's network or connect to the ISP's network. Technically, there was no security concerns at that time. But ISPs soon they came to the realization that, hey, it's not really safe that anyone can dial a phone number and dial into the network or dial into the network just by calling a phone number. So they wanted to have some sort of an authentication done before a user connection was allowed. That led to the creation of Radius. That's why you still see that name there, remote access dial-in user service. And nowadays, obviously, we don't have dial-ups, we don't have modems, right? We have fibers, fiber to the home service, etc., etc. But Radius has since been repurposed, kind of, to be used inside of enterprise networks. Okay, and again, that's going to be really the basis of our everything that we talk about secure network access. So how was Radius standardized? I'm pretty sure, everyone here is or should be from a networking background, so everyone would recognize this. IEEE, right? These folks, they do standards, internet standards, protocols, etc., standardize them. So IEEE standardized to use Radius for doing authentication, to carry authentication traffic. Okay, so they standardized a method to implement EAP, Extensible Authentication Protocol. Typically, you will see this written as EAP-OL, Extensible Authentication Protocol over LAN. So IEEE standardized a method to use EAP-OL using Radius to carry authentication traffic. So typically, you would see EAP-OL not called out a lot, okay? But when we think about network access AAA, or whenever from now on, if you ever see network access AAA being highlighted, the first thing that should come to your mind should be EAP-OL. Or a much more better term, or a much technically relevant term that you would see being used a lot is going to be IEEE 802.1x. Or sometimes you would see this written as .1x as well. So IEEE 802.1x or .1x is what you use to implement secure network access, which in turn makes use of Radius. And the thing here is, in the very first place, I told you that these two protocols, they have their own distinct use cases. Tacacs Plus is typically only used for device administration. It's not used for network access. And the reason for this is IEEE 802.1x cannot use Tacacs Plus. It must use Radius to implement network access AAA. Okay, so that's why you have two distinct protocols for two distinct use cases, two distinct AAA options, or to implement two distinct AAA options. Okay, so this is from an enterprise perspective. Service providers implement same thing, right? So even though service providers no longer are doing the modems or dial-up, but they're still doing a lot of other things. They still would want to do authentication within their environment. So an equivalent to Radius. So when a service provider wants to implement 802.1x in their environment, obviously they would not use Radius. They would use diameter. That's the service provider equivalent to Radius for implementing IEEE 802.1x in their environment, or to implement network access AAA in their environment. Okay, and obviously, this is something that we will not spend time on because, again, we are not talking from a service provider environment perspective. We are focusing on enterprise. Okay, so Radius is what our focus is really going to be. Okay, now a couple of additional things from a differentiation perspective between Tacacs Plus and Radius. So Radius is UDP based. Okay, and you would typically see two different sets of ports that will or that can be utilized. So one set could be 1812, 1813. Okay, and I'll explain why do you need two ports, and here why do you have a single port. The other set is 1645 and 1646. So 1812, 1813, they are the older ports. 1645, 1646 are next gen ports. No real differentiation or no real difference in whether when you would see Radius working over either of these ports. There's no real difference. Okay, if we talk about from something like ISE, ISE supports both. So if you have in your environment some legacy infra devices, some very, very old gen routers, switches, firewalls, who still understand 1812, 1813, ISE will still be able to function and talk Radius with them. And typically for any newer generation devices, you would typically have 1614, 1646, 1645, 46. Okay. But typically see them in logs and everything. Okay, there really is never a problem which set of ports you use. They don't really offer anything beneficial, really. Okay, they're just that layer 4 information. That's it. But the main thing is it uses UDP and Tacacs uses TCP. So being UDP, it is obviously not a reliable kind of a thing, Radius. It has its own ways to achieve reliableness, but from a transport layer perspective, it's UDP. Another differentiation is with respect to how it carries the credentials. So Tacacs Plus, here we highlighted that it encrypts the payload, and payload would typically be your credentials. Radius only hashes the password field. So not even the username, just the password. So it will hash it, run a hashing algorithm, whatever the hash value is, it will add that inside of the packet, and then it will send that to the AAA server. Okay, so technically, the user ID is still exposed. Okay, so I could take a packet capture and I could see what the user ID is. And if you, on your network, if you are not careful enough to implement a strong hashing algorithm, and maybe if you used a weak hashing algorithm, then if I am uh, even decently skillful, I should be able to crack that hash value and figure out the password or any other matching value that would give me that same hash value. Again, there are ways that which you secure Radius, okay, depending upon how you implement it. So you technically, even though it does the hashing of the password only, there are further ways in which you will protect them, and that is also part of the recommendations or a best design practice that we have on how you should implement Radius properly. Okay. Any questions? Anyone? Not too confusing? I'm pretty sure if people don't have or won't have much experience with Radius and Tacacs would have ever wondered the difference between them, they should have cleared out some doubts. Okay, so that's why it's typically very important for you to understand this first before you even understand what ICE does. Okay, because ICE at the end of the day is implementing these two protocols. Okay, so ICE is the guy here, AAA server. Okay, so as complex as ICE is and the whole solution, understanding this does ease a little bit of complexity. Okay. Now let's see how these two protocols, they differentiate. Okay, so I'll show you the flow of messages, how the message exchange happens. How does this client server behavior or this client server model really function? And then you'll be able to understand the difference between them as well, a bit more. So I'll first talk about Tacacs. Okay, Tacacs has a bit more extensive messaging than Radius. Okay, so we have our good old stickman. He's trying to access, let's say, a router, and maybe he's trying to do SSH, or I'll write SSH at the bottom. And then we have a AAA server here. And again, I'm not writing ICE at the moment. We're just talking about purely in generic terms from just a AAA perspective. And here you could substitute this with anything, maybe ClearPass, maybe any other AAA server. Obviously, he won't do Tacacs, but kind of get the flow, the idea of the flow, how it would be. So this user here, he will obviously initiate an admin session, which would be either over Telnet, or it would be SSH, could be HTTPS, etc. Here, this is a AAA client. Okay, so radius is all, or Tacacs is always going to be between the client and the server. So admin session, the first thing, the AAA client is going to send or initiate the first Tacacs message. Obviously, once this gets here, the AAA client is set up with the AAA server IP address, etc., etc. And since this here is going to be TCP port 49, there would obviously be a three-way handshake that will need to be completed before we go into this first message. So I'm skipping that. Obviously, it's understandable, it's TCP, so you need to have that three-way handshake over port 49. Okay, so for completeness sake, I'll still write that here. Okay, so I'll just write three-way hand. Okay, so once that three-way handshake happens in both directions, the AAA client is then going to initiate the first Tacacs message, which is going to be a start message or a start packet. From this AAA server's perspective, when he first sees that start packet, the AAA server, or for this AAA server, it basically tells the AAA server that there's a user who's trying to connect to the AAA client. This user is trying to connect to the AAA client. So from AAA server's perspective, this message acts as telling the AAA server that there is an incoming Tacacs authentication. So this is an authentication packet. I'm going to write auth C for it. The AAA server is going to then respond with a reply. Authentication. And it's going to reply to request username. When the AAA client receives that message, it displays to this user a username prompt. Okay, so the user here, at this point in time, it will enter some sort of a username. The client is going to send a continue back at this time. It has already started the Tacacs. This continue, this is part of this same, what we call as a transaction or a same Tacacs session. So he sends a continue, and within this continue, it will add the username. Okay, again, it's just the username first. So at this point in time, authentication cannot happen. For authentication, we need credentials. And credentials is a combination of username and some sort of a credential. And credential could be, in addition to the username, it could be a password, could be a signature, could be a certificate, could be a biometric, could be an OTP, could be a PIN. The AAA server is going to send another reply. And this time, they are going to say or tell the AAA client to get the password. When the AAA client receives this message, it will prompt the user to enter password. Okay, so the user is going to enter whatever the password. Now, similarly, here there will be a continue packet that will be sent, which will carry the password. Okay, so at this point in time, the AAA server will have username and the password. It can check its database to verify those credentials. Okay, taken the fact that the user has entered the correct credentials, the AAA server can then send a reply and then say pass if the credentials are correct. So once this happens, at this point in time, the authentication completes. Okay, could write it a little better. Okay, so if you're going to see from a messaging perspective, there are only three types of messages that are utilized in the authentication in Tacacs Plus: start, continue, and reply. Start is always going to be used to begin the authentication request. It will tell the server that there is an incoming authentication request. This will always be from the client to the server. Replies are always going to be from the AAA server to the client. And through these replies, the AAA server will ask username, password, or any other additional information. And then the continue messages are always going to be from the AAA client to the AAA server, which will be responses against the reply messages. Okay. And then this last reply message, this will have additional attributes or values. Okay. So one, you see this as pass. This will typically not be a pass in here. Okay. This reply here, it will have one of these values. Could be an accept, which will basically be the authentication succeeded. Whatever the credentials were provided, they were good. And now the authorization can start. If this client is configured to do authorization, okay, you can do AAA split up as well. Let's say I don't want to do authorization. I only want to do authentication. I could do that as well. Okay, so it's all based on this AAA client's configuration. Okay, that's what the accept is. If the credentials are incorrect, the AAA server can send a reject. It would basically mean the user authentication failed. Which typically could happen if someone fat-fingered the password, fat-fingered the username, for example. So depending upon how the AAA client is configured, you a lot of times configure retries. Okay, so this whole process, once this fails, this whole process needs to start again. From the username prompt to the password and everything. There could also be an error attribute that could be there, which could mean that there was some sort of an internal process error that happened on the AAA server, which necessarily does not mean that the user authentication failed or the user provided incorrect credential. Okay, so this will typically prompt the AAA client to retry the authentication. Okay. Now, once the authentication happens, we obviously, depending upon how the client is configured, and taken the fact that the client is configured, we would do authorization. Any questions from the perspective of authentication flow?
Arun, what was the error about? Sorry, I couldn't get that.
This error?
Yeah.
Think of it like there might have been some sort of an internal process error, or maybe some sort of a process got hung on the server side. Okay, so it was not able to process the authentication request correctly, which
Okay, so
is not
this is between client and server, not anything to do with the user, right?
correct. This has
Okay.
to do with the user, the reject. This is when
Oh.
the user basically entered either an incorrect username or an incorrect password. This has to do with the internal process with the AAA server. Okay, maybe there is some performance issues going on. Maybe there's a CPU spike. Maybe disk usage is high, etc., etc. And then the server is not able to process the request correctly. So it basically throws that error.
Okay, got it. Thank you.
Now let's come into the authorization. From the authorization's perspective, let's use a different set of these. So once the authentication completes, we can now go into the authorization. There are different set of messages that will be used for authorization. The first one is going to be a request. Okay, and for authorization, I'm going to write auth Z. Okay, so auth C for authentication, auth Z for authorization. And in this case, so let's say this is a router, so it will be on a Cisco router. Once you have done the authentication, you need to see some sort of a shell prompt, something like this or something like this. Right, this is privilege level 1, this is privilege level 15. Whatever shell or whatever prompt the user needs to see, that need to be authorized as well. So after the username and password, the client is not going to provide any shell until and unless it gets the shell information from the AAA server. So this first request is to request a service of the type shell. So basically, the client is requesting what sort of a privilege level shell should I display to this user? The AAA server is going to send obviously a response to this. And one of the response messages is a pass add.
Or please, I don't really understand service shell. What
So,
do you mean?
so when you log into a router,
Yeah,
right, what is the prompt that you see? It is something like this, right? You
yeah, right.
do an enable,
Yeah,
you go into this, you do a conf t, and then you enter something like this,
Yes.
right? So these
Yeah.
are shell prompts. So when you are in this type of a prompt, this basically means from Cisco router's perspective, privilege level 1,
I see. Thanks.
right? This
Yeah,
here,
got it.
when you do enable and you go into this is known as an exec privilege mode or a privilege exec mode, which is a privilege level 15. So which of these prompts should be displayed to the user? That's what the client is basically requesting at this stage from the. So, and in this response, basically the server is going to say, and it's going to say privilege 15, for example. So at this point in time, the user will now see the prompt on the shell. Okay. And in addition to these messages, the client is also going to start logging. So it's going to send a new request message for the type accounting. And it's going to say start. Basically, it's telling AAA server to start accounting for or start logging this session for Tacacs. Then the server is going to just send a response and say success. Now the user here on this prompt, he types show run. This command execution will depend upon an authorization as well. So that's why I said with Tacacs, you can do command level authorization. You can be very, very granular. So when the user types show run, the client initiates a new request. And this time it is requesting for a service type of command. Previously it did shell, now it's doing a command, and then it's sending the command that it needs authorization for from the AAA server. So it's basically saying, asking the AAA server, is this user allowed to run this command or not? If he is authorized, AAA server is also obviously going to send a response similar to what we saw here, and it's going to say pass add, which will basically mean yes, he's allowed. So at this point in time, the command will get executed and the user will see the output for the show run. And this piece here, it needs to be accounted as well or logged as well. So the AAA client is going to do a request for accounting. The logging has already started. So we want the logs to be added to that same session. So we are going to say continue. And there's going to be a response which says similar to above, success. Okay. So obviously, if there is a command that this user enters, which he is not authorized to, then he could respond, he could receive something like a fail. which would be a reject. So at which point in time, if there is a reject, so let me add that here. So let's say this user is not authorized to go into the config mode. Let's say he types in conf t. Going to be a new request. Service is going to be the same for a command. And then switch is going to ask whether he is authorized to run configure terminal or not. If let's say he is unauthorized to enter that command, we'll get a response. And we'll simply say fail. At which point in time, the AAA client is going to display to the user command not authorized. And obviously, there would be or this information will be logged. Okay, that's what the authorization and accounting looks like. So if you're going to see within the authentication, we had 3 different sets of messages and then a AAA handshake, sorry, a 3-way handshake that happened because of the TCP nature. Start, reply, and continue. In the authorization phase, we only have 2 types of messages, request and response. Obviously, requests are always going to be from the AAA client to the server, and response is always going to be from the server to the AAA client. And you would always see this service attribute being added, which will basically be what the AAA server is requesting authorization for. One time it was the shell or the privilege level that the user should be provided, and what sort of a prompt, what type of prompt it should be able to see. The other time it was command, since the user was now entering the command.
So Arun, so every time a user is trying to enter something, so this communication will be happening
Correct.
between. So it's not like once the authentication is done, it will give a set of permissions together to the
No,
router. Okay.
you can still do it if you want to. Let's say if you have a super admin or someone, okay, who is basically authorized to run all the commands. Okay. Still, every time he will enter a command, there will be a separate authorization that will need to happen. So the nature of Tacacs Plus is this. So that's why it's very granular in nature. Per command authorization can be offered or can be implemented with Tacacs Plus. That's the power of Tacacs Plus, basically. And if you're going to also notice, the authentication and authorization are separated. Okay, so first authentication happens, and completely separately, authorization happens and accounting happens. Okay, so separate authentication and authorization with Tacacs Plus. now if we talk about radius, or if we see a comparison with respect to how radius would work for a network access, maybe for a wired connection, for a wireless connection, remote access VPN, for example. Okay, so we'll create that same stickman here. Okay. This time, I'll make a switch because obviously a user will not connect to a router directly for network access. Switch also talks to AAA. So in this case, the switch is now a AAA client. If this would have been wireless, this could be an access point, or it could be a wireless LAN controller. If we are trying to do remote access VPN, this could be a firewall, which will terminate the VPN down. Okay, so this is where we would run radius. Or this is where the communication of radius happens, just like previously. AAA client, AAA server, that's what the radius goes in. Okay, so this user connects to the SSID, maybe plugs in to a desk switchboard. That's basically start of an internet connection or a network connection, sorry. Okay, the NIC enables wired, wireless, whatever. This causes the switch to initiate the radius communication. So he will send a radius access request. Within this access request, it will carry the username information, password information, and it will also adds a service type field as well, which basically notifies to the AAA server what sort of a connection this is happening. And I'll explain this a bit more later on, bit more details, so you'll understand what service type is. This is not the same thing as the service that we saw in the Tacacs Plus authorization. So they both are not the same thing. Okay, so username, password, the AAA server does the authentication. And then the AAA server also is doing the authorization. So there is no separate authentication and authorization in Radius. This single message, this acts for both authentication and authorization. The AAA server at this point in time, depending upon what sort of policies and everything we have, it can send a access accept or a reject. And then once it does that, both authentication and authorization complete. And they can now be traffic flow from the endpoint or that end device. Once this happens, obviously, there needs to be accounting as well. So the AAA client sends an accounting request and says start logging. We get an accounting response, which is basically just like an acknowledgement or an ACK. If this user disconnects from the networks, let's say the user disconnected from the Wi-Fi, or maybe took out the cable from the NIC, the accounting needs to stop as well. There will be a new accounting request, and this will typically happen for Tacacs as well. Stop, and then obviously the AAA server is going to send a. It's really an access response and not an accounting response. Okay, so authentication and authorization happen at the same time in Radius. So you don't get the same level of granularity that you get with Tacacs Plus here. Another reason why Radius is not used for device administration. You can use it. Okay, so you can use for network access Tacacs Plus cannot be used because 802.1x does not support Tacacs Plus, only supports Radius. For device admin, you can use Tacacs Plus or Radius. But the problem with using Tacacs or with Radius is you do not get that command level granularity. You won't be able to get this because authentication authorization happens at the same time, in the same step. So that's why we have differentiated those use cases in such a way that the best protocol that is meant to effectively achieve the use case is used against it. So the device administration, engineers, admins, they're entering commands. I need to see all of that. I need to be able to authorize all of that. I need to have that command level authorization. That's why I would always and always prefer to use Tacacs Plus, even though I can use Radius as well, but that will not give me command level authorization. Okay, so we exclusively use Tacacs Plus, or we exclusively use for device administration Tacacs Plus. For network access, we don't really have any options. We have to use Radius because 802.1x does not support Tacacs Plus. Okay, so authentication authorization, you have access accept, again, which is always going to be from the client to the server, the access request. Okay, and the access accept typically would be, or always is going to be, from the server to the client, and it will tell a successful authentication. Reject will indicate a failed authentication. Failed authentication and no authorization can be done, obviously. Authentication needs to be successful for authorization to happen. successful authentication does not mean or does not guarantee successful authorization as well. Remember these two things.
Arun, I have one question.
Mm-hmm.
I don't really understand the reason why we cannot use the tax in network access. Why?
Because of this here. IEEE 802.1x.x can only support radius. It does not understand or does not support Tacacs. That's why I cannot use it for network access.
So the Tacacs Plus is a Cisco proprietary or is
Correct.
it oh,
Tacacs Plus is Cisco proprietary. I did write it somewhere, I think.
so what is the alternate like for other vendors they'll be using radius
They could do
instead of
Tacacs, just Tacacs, not
okay.
Tacacs Plus. Okay, so Tacacs is the kind of like the vendor neutral version. Tacacs Plus is Cisco proprietary, or you could use Radius.
So what's the big difference with Tacacs and Tacacs Plus? Is there any enhancement done by the Cisco?
So I will tell you the difference. Tacacs Plus is Cisco proprietary.
Okay.
Okay, so Tacacs Plus was created and was inspired by Tacacs. So Cisco took it and then they created their own version, but there is no compatibility between the two. Okay, so that's why if you have a device that can only do Tacacs, and if you use it with something like ISE, that is not going to work. Okay, so Tacacs Plus in a pure Cisco environment, great. Outside of a pure Cisco environment, you can still do device administration, AAA, still implement AAA, but you'll have to use Radius. Okay, but that's the difference between the message types, Radius and Tacacs. Okay, the primary one, like I mentioned a couple of times, is that in Tacacs, the authentication and authorization is separate. Okay, you first do authentication and then separately you do authorization. In case of Radius, you do both at the same time. So when this client, it sends an authentication request, this is really an authentication request. The client is expecting to receive a response for authorization in turn. Okay, so it's not waiting to receive an authentication response and then send an authorization. It just sends this single request and then it expects to receive a response for an authorization, whether the authorization was successful, it failed, etc. Another difference in the message types is primarily from an authorization perspective. In Tacacs Plus, you have this service. In Radius, we have this service type. And this is really a function, or again, it's a service that is being requested or that is being highlighted to the AAA server. And there could be a variety of different values which could go into service type. So for example, if this user is obviously authenticating, here it would be doing 802.1x. Now, this AAA client needs to tell the AAA server what sort of a request this is. If this request is 802.1x, then the service type is going to be written as frame. There can be non-802.1x authentications as well. So there could be such devices on the network which cannot understand 802.1x, which cannot do or do not support 802.1x. So it's a AAA client which basically tells that. So a second common authentication that we will see later on is MAB, which is an example of a non-802.1x. So if this user is not doing 802.1x, then that needs to be told to the AAA server. So in that case, the AAA client could add the service type as call check. So when the AAA server receives a request with framed, it knows that it needs to evaluate or do, or the client is trying to do 802.1x. Versus if it receives an access request with a service type of call check, it knows that it's a non-802.1x client that is trying to connect to the network. So these are mostly the two common ones that you would see being used a lot. And when I say a lot, exclusive. Okay, there are some others as well, but you typically would not see them being used. There is one could be from a login post. Okay, so with ISE, with Radius, you can also do something that we call as a web authentication. Okay, we'll understand that use case. Very important. Very important use case, very widely deployed use case across implementation consistently. Okay, there is something that we call as outbound, which will be used for a different type of web authentication, which we call as local web authentication. Okay, so these two you typically will not see being used nowadays a lot. So these two are the more common ones that we'll see. And I'll show you how you can see that in the logs, how you check in the logs. So just by looking at the logs, you can actually figure out a request was from an 802.1x client or from a non-802.1x client. Okay, so this service type is of utmost importance within Radius. And nothing but it's an attribute. And it will have some sort of a value against it. Okay, so that's why within Radius, a lot of these that you see, this is again an example of attribute and value. We call these AV pairs. Attribute value pairs. So Radius protocol or in AAA, be it Tacacs or Radius, Radius has more number of these. It has many, many, many attributes that are used to convey lots of different information. Okay, so these we call them as attributes, and then any values against these attributes, they together form an AV pair or an attribute value pair.
So, Arun, in Radius, so when the client is trying to use 802.1x, so what kind of services actually it belongs like in Tacacs, like we in this example we have gone with SSH or those things. So
Mhm.
in real world, like what kind of example?
Whatever can be used to do network access, which is any sort of a wired access, right? User trying to connect to a switch port, to a desk port, that will classify as wired access. Trying to connect wirelessly, or trying to connect remotely, right? These are the three ways in which you can have network access, right? So that's what we secure through Radius. From comparison, Tacacs perspective, it's for device administration, for network device administration, for infrastructure device administration, which could be either through SSH, Telnet, could be HTTPS access as well. Okay. If you're trying to log into a web page of, let's say, a firewall or a firewall management, even when you would log into something like ISE web page, okay, that would typically be HTTP or HTTPS access, which you are trying to do for device administration. So it's a very clear distinguished functionality that we have within both of these protocols. Radius for network access. Network access could be either of these three ways. That's what we try to do when we say, or this is what we are trying to protect when we say secure network access. In comparison, when we have Tacacs Plus, that's what we do for device administration. Anytime we are trying to administer a network device or an infrastructure device. Right? Any questions? Anyone about anything that we talked about today? So I don't want to, you know, uh, do a lot of confusion and cover a lot of things today for the first day as itself. So just to summarize, Radius used for network access or used to implement network access AAA. It is UDP based, two separate set of ports that can be used. And yeah, one more thing from a port perspective. So this is the part where 1812 or 1645 will be used for authentication and authorization. This is where 1813 or 1646 will be used. So if 1812 is used, obviously 1813 will be utilized. Okay, so they are both used in pairs. So you cannot use 1812 and 1646, or you cannot use 1645 and 1813. Okay, they have to be in pairs. So that's what the pairing is. That's what the difference is with respect to Radius and Tacacs as well. Radius has two ports that are used for authentication, authorization, and for accounting. 1812, 1813, that's one of the pairs, and then another one is for 1645, 1646. Okay, can use either of them. Older devices will use 1812, 1813. Newer next-gen devices, newer firewalls, load balancers, routers, switches, they typically understand 1645, 1646, or both. So ISE does both. specifically to still have backwards compatibility. Okay. On the other hand, Tacacs is TCP, it's reliable, and it uses just a single port, port 49. From a secure perspective, natively, Tacacs Plus encrypts the entire payload, which basically means it encrypts the credentials, which is the user ID as well as the password or whatever the credentials might be. Radius only hashes the password field. Nothing is done to the user ID. Okay. Another difference that we saw between them was Tacacs Plus separates authentication and authorization. You first do authentication. Once that completes, separately, you would then do authorization. Radius, as we saw, combines the authentication and authorization in a single phase or a single step itself. And then one last time, use case or primary use perspective, Radius you would always use for network access or to secure, protect network access. Tacacs Plus you would always use to implement device administration AAA. Okay. Any questions?
Around one question. I'm not sure if this is a stupid question. So, a user is trying to connect to a router or switch as for a administrative purpose
Mhm.
from I mean like LAN network with a wired connection. So what will be like? There will be two separate doing here. I mean Tacacs and Radius separately, or
Yes. So if one he is trying to do network administration, which would be he would either do SSH Telnet or HTTPS. Okay. Then that would use Tacacs versus if he's trying to connect to that, let's say the same switch and is connecting to a switch port to get network access, that would do Radius. And it really is dependent upon the configuration. So that switch will have separate configurations for Tacacs Plus and Radius. So it will be able to differentiate when it needs to do Tacacs, when it needs to do Radius. But yes, if it's a single user trying to do two different things on that same switch, it will do both, or the switch will do both Tacacs and Radius separately. They are not, or they would be, or they basically function independently.
okay, got it. Thank you.
Okay. Anyone else has any questions? Okay. So we'll probably wrap up for today. Okay. Just go over, just review some of the information that I have mentioned. Cisco has lots of documentation. You would find lots of documentation online. Okay. And just to go over, just to see, and get that understanding in. And then obviously we'll go over and, continue with this tomorrow, see some additional things, talk about ISE and everything. Okay. Thanks, everyone. Cheers.